Information systems development refers to the process of building an information system to solve a business problem using a systems approach. The systems approach looks at the entire business process as one complete system rather than focusing on only one part. This helps ensure that the solution fits the organization's overall needs. Before an information system is developed, several important steps must be followed. First, the problem must be recognized and clearly defined. Next, different alternative solutions are developed and evaluated. Then the best solution is selected. After that, the selected solution is designed. Finally, the solution is implemented and evaluated to make sure it works effectively. The System Development Life Cycle, or SDLC, is a structured process used to build and maintain information systems. It consists of five main stages, which are followed step by step. The first stage is system investigation. At this stage, the organization identifies a problem or opportunity and decides whether a new system is needed. The second stage is system analysis. Here, the current system and user requirements are studied to understand what a new system should do. The third stage is system design. This stage focuses on planning how the system will work, including its structure, inputs, outputs, and processes. Next is system implementation, where the system is actually built, tested, and put into use. The final stage is system maintenance. After the system is running, it is regularly updated, fixed, and improved to ensure it continues to work well. The SDLC provides a clear and logical framework for developing information systems from start to finish. The system investigation stage is the planning stage of system development. At this stage, a project request or proposal is submitted to a steering committee. The steering committee is responsible for evaluating and assessing all possible system development projects that an organization may want to carry out. A project manager usually chairs the steering committee. This role involves deciding which projects to approve, setting priorities, allocating resources, and monitoring project progress. During this stage, a project development team is formed. A system analyst gathers, analyzes, understands, and summarizes system requirements. A system designer creates the system architecture and detailed designs to meet those requirements. The investigation stage also includes a preliminary feasibility study. This is a brief evaluation of the proposed system to understand how it may work and whether it is practical. Feasibility helps determine whether the project is suitable for the organization and worth continuing. In this phrase, system investigation helps the organization decide whether a project should proceed before investing more time and resources. The system analysis phase focuses on understanding why a new system is needed by clearly identifying its goals and objectives. During this phase, the system analyst studies how the current system works. This is done by collecting data and information from users and existing documents. Next, the analyst identifies user requirements, which means understanding what users need and want from the new system. Based on this understanding, the analyst recommends a solution. This solution is usually expressed as a logical design or logical model. A logical model acts like a blueprint of the system. It explains what the system should do, but not how it will be built. It is important to know that data gathering happens before data analysis, ensuring that enough accurate information is available. During the system analysis phase, analysts use different techniques to gather information about the current system and user needs. One common technique is reviewing documentation. Existing documents such as reports, charts, memos, and manuals help analysts understand how the system currently works, including its strengths and weaknesses. Another method is observation. The analyst watches how daily work is actually done to identify problems and opportunities to improve business processes. Interviews are also widely used. The analyst talks directly with clients and end users, asking open-ended questions to better understand their needs, issues, and expectations. A survey involves distributing questionnaires to many end users. This approach can reach a large number of people quickly. Although not everyone may respond, Joint Application Design (JD) brings together representatives from different departments to share ideas and discuss requirements collaboratively. Finally, research involves studying external sources such as journals, conference papers, and magazines to gain additional insights and best practices. The outcome of the system analysis phase is a clear set of requirements that describe what the system is expected to do and how well it should perform. These requirements explain the expected attributes and capabilities of the new system. There are two main types of system requirements. The first type is functional requirements. These describe what the system can do. For example, the system may allow users to log in, store customer data, process transactions, or display a homepage. In simple terms, functional requirements describe the functions and features of the system. The second type is non-functional requirements. These describe how well the system should perform and the constraints it must meet. Examples include how fast a web page should load, how secure customer data must be, how many users can access the system at the same time, or how often the system should be available. The system design phase focuses on creating the physical design of the system. At this stage, the goal is to explain how the system will actually be built and implemented to meet the requirements identified earlier. It turns ideas and requirements into detailed plans for development. The main output of system design is a set of clear specifications that developers can follow. These include the details about files and databases, input forms and reports, documentation and procedures, as well as hardware, software, and networking components. System design normally involves three key activities. Interface design focuses on how the system looks and how users interact with it, such as screens, menus, and links. Program design describes the detailed steps and logic that programmers need to code. Data design defines what data is needed, how it is organized, and how it will be stored. The system implementation phase is where the system design is turned into a working software system that is installed on hardware and ready to be used. This phase usually starts after users have accepted the system design, meaning they agree that the system meets their needs. During system implementation, several important activities take place. First, the organization acquires or develops the required hardware and software. Next, data conversion is done to move data from the old system into the new system. Users are then given training so they know how to use the new system correctly. A conversion strategy is chosen to decide how the old system will be replaced by the new one. Finally, documentation is prepared for both users and IT specialists. During system implementation, organizations must decide how to switch from the old system to the new system. This is called system conversion. One option is parallel conversion. In this approach, the old system and the new system run at the same time for a short period. This helps ensure the new system is working correctly before the old system is fully stopped. However, this method can be costly because two systems are maintained at once, and it is usually used only when an existing system is already in operation. Another option is phased-in, phased-out conversion. Here, the new system is introduced one module at a time. As each new module becomes operational, the corresponding part of the old system is removed. This process continues until the entire new system is fully running. This approach is commonly used in areas such as accounting and finance.
Another option is direct changeover. In this approach, the old system is stopped completely and the new system is introduced immediately. This method can save costs because only one system runs at a time. However, it is risky because if the new system has problems, there is no backup. Lastly, organization also can choose pilot conversion here. The new system is first implemented in a small part of the organization, such as one department or division. This allows the system to be tested in a real environment but with limited risk. If the system works well, it is then rolled out to the rest of the organization, either gradually or all at once.
Documentation is an important part of the system implementation phase. It involves collecting and summarizing important data and information about the system. There are two main types of documentation. The first type is user documentation. This is prepared for end users. It explains how to use the system step by step and helps users understand common features and error messages they may encounter. The second type is system documentation. This is prepared for IS specialists, such as system analysts, designers, and developers. It contains detailed technical information, including system design programs, source code, system flow, data dictionary, process descriptions, and reports. System documentation helps technical staff understand the system, maintain it, and make changes when needed. System maintenance is an ongoing activity that takes place throughout the entire system development lifecycle. After a system is implemented, it does not remain perfect forever. Errors will always appear, and these errors must be identified and corrected as the system continues to be used over time. There are four main types of system maintenance. Corrective maintenance focuses on fixing errors that users discover while using the system. These errors usually happen because of problems in system design or logic. Adaptive maintenance involves adding new features or making changes based on user feedback or changes in the business environment. This type of maintenance also requires monitoring system performance to ensure stability and efficiency. Perfective maintenance aims to improve system performance, making the system run faster, more efficiently, and more reliably. Preventive maintenance focuses on reducing the risk of future system failures and extending the useful life of the system maintenance. Continues as long as it is cost-effective. When the cost of maintaining a system becomes the same as or almost the same as the cost of buying a new system, the organization may decide to replace it. In simple terms, system maintenance ensures the system keeps working well, adapts to change, and remains useful over time. Sometimes it is not practical or beneficial for an organization to build a system internally, which is also known as in-house or custom development. In such cases, organizations can choose external acquisition. This means purchasing a pre-packaged system from an external software vendor such as IBM or SAP. Using pre-packaged software can save a lot of development time and effort. However, the software may still need to be customized to match the organization's specific requirements. Another option is outsourcing or offshoring. This involves hiring external companies, either locally or overseas, to develop, manage, or maintain information systems. Outsourcing allows organizations to focus on their core business activities while specialists handle the IT work.